Hello there. In the coming few videos, we will try and categorize the machine learning algorithms with some examples. They fall into two large categories called supervised and unsupervised. Now, to understand this concept in a relatively simple example, let's imagine that the algorithm is a child. Now, let's say that you have a basket of tomatoes and potatoes, and let's say that you want the child to separate the tomatoes and potatoes into two different baskets. Okay. Now, for supervised learning, you would first show the child how a tomato and a potato looks like. Then you would say the child to do the task for you. In unsupervised learning, you would tell the child, hey, listen, go and group them into different categories. So you're not actually telling the child how the categories look like, you're just leaving it to the child to decide. Ideally, the child would group the similar items together, but would not know which is the tomato and which one is the potato. For the unsupervised algorithm, these are just two similar groups. So this is a rather simple example of supervised and unsupervised learning algorithms. Now, on top of that, based on their input and output relationship, the algorithms can be categorized as linear and non-linear. The relationship between two variables or the function can be categorized as linear or non-linear depending on the exponent of the function. So if the exponent does not exceed 1, it is called as linear, and if it exceeds 1, it's called non-linear. Let's take a quick example and simplify this. In this example, we have two variables. On the x-axis, we have the timeline, so first year, second year, and third year, so on. And on the y-axis, we have the price. Now let's first take the linear example. So if you see, the price in year 1 is 10 and year 2 is 20, 30, and so on. So the delta change between the year 2 to year 1 is $10 and so on till the year 5. So there is a constant change of $10 every year. So if you actually plot this in a graph, it's going to be a straight line, x being the time, y being the price, and the function is going to be y equal 10x. So if we take this example, year 3, y equals to 30 and x equal to 3, so 10 into 3 is 30. Now we actually plot the polynomial function for this graph. The power of x here is 1, hence this is a linear function. Now let's go to the non-linear example. So the same variables, year versus price, but here if you see the delta change, it is not linear, it is non-linear. So on the first year it changes by $10, on the second year it changes by $20, and on the year 5 it changes by $50. Therefore you see a non-linear slope here, and the polynomial function for the slope is y equals 5x power 2. So therefore this exponent is not 1, it's greater than 1, hence this function is non-linear. In the next video we'll take a look at supervised learning algorithms.